Hello everyone. In today's session, let us learn about the correlation analysis, where we are just going to use peer correlation coefficient concept. So before letting into the correlation coefficient, let us go with the scenario of what do you mean by covariance. So covariance. Covariance measures the relationship between two random variables and the extent to which they can change together. So it is defined like the relation between two variables. So that the change in one variable is equal to the change in the other. Right. So the formula to calculate the covariance is expectation of x minus expectation of x, y minus expectation of y. Okay. So this is actually we can write the covariance is this thing. Covariance of x comma y is nothing but expectation of xy minus expectation of x into expectation of y. So there are certain properties of for the covariance. Covariance of x comma y is equal to expectation of xy minus expectation of x into expectation of y. If it is covariance of x onto x itself, it is nothing but the variance. Expectation of x minus expectation of x the whole square. And if it is with the addition of a constant a and constant b, then the covariance of x plus a and comma y plus b is nothing but covariance of x comma y. Whereas the covariance of combining these two, multiplicative covariance of ax plus c comma by plus d is equal to ab covariance of x comma y. Like we have the property for the variance, right? Variance of ax plus r minus by is nothing but a square variance of x plus b square variance of y plus r minus 2ab covariance of x comma y. If x and y are independent, the covariance of x comma y is equal to 0. And if xy are independent, then the variance of x plus y plus or minus y is nothing but variance of x plus or minus variance of y. And let me now define the correlation. So the two variables vary such that the change in one variable affects the change in the other, and that variable is said to be correlated, right? If there is a relation only, then one change in other, change in one will affects the change in the other, right? So, the correlation is a statistical tool which is used for measuring the relationship between two variables. So, we have the relationship between two variables, whereas it may be a positive or negative. And also, a greater change in one variable results in the corresponding greater or smaller change in the other one. So, it's defined generally as a relation, correlation. And we are supposed to calculate the coefficient of the correlation, and which is the degree to which the two variables are interrelated is measured by a coefficient which is called as correlation coefficient, and it is represented by r or else rxy or else r of x comma y. In some textbooks they follow rho of x comma y or rho. These all represents the coefficient of correlation. And we have few properties for the correlation coefficient, like the range of the correlation coefficient will be minus 1 to 1. It cannot be beyond this range. If r is equal to 1, then it is perfect positive correlation, and if r is equal to minus 1, then there is a perfect negative correlation. And if r is equal to 0, then it is uncorrelated. That means they are independent. There is no relation between x and y. Okay, so come to the next. If the correlation coefficient is positive, then x and y have same direction. If it is negative, then their x and y variables moves in the opposite direction. So the correlation coefficient is just pure a number and is not affected by change of origin or scale in a magnitude. Okay, so now let me go with the scatter diagram, which refers here positive correlation, negative correlation. There is no correlation, and if it is perfect positive correlation, the scatter diagrams represents here. And the correlation coefficient can be calculated based on many methods. Here in your syllabus, we are just going to use Karl Pearson correlation coefficient, and it is also known as a product moment correlation coefficient, and it is suitable for quantitative measure, and it is also suitable for the linear relationship estimation, and where it is defined as r of x comma y is the covariance of x comma y upon sigma x sigma y. We know what do you mean by the covariance of x, provided their variance should not be equal to 0. Covariance is nothing but expectation of xy minus expectation of x, expectation of y upon sigma x, sigma y. If a given linear relationship ax plus by plus c is equal to 0, we can write it as an equation of line like rewrite as y is equal to mx plus c, where m is a slope and c is an intercept, right? And if m is greater than 0, then r is equal to 1 exactly. And m is less than 0, r is equal to minus 1. If it is exactly equal to 0, then your relation is 0. And we'll go with the problem. First one to explain the correlation coefficient. So the joint probability mass function of x and y is given. So it is minus 1 and 1, 0, 1. The corresponding probability values are given. So to go for it, I have to find expectation of xy, expectation of x, expectation of y, and variance also. So as it's a joint PDF, a discrete case, we'll calculate what is your marginal PDF of x and marginal PDF of y. So marginal PDF of x is calculated by summing these two values along the row, and marginal PDF of y is calculated along the rows or the columns. For the marginal PDF of minus 1, it is 3 by 8, and it is for 1, it is 5 by 8. And the overall total should be 1. And so expectation of x is nothing but x into p of x, whereas expectation of x square into p of x. Similarly for y. So expectation of x into p of x is nothing but 0 into p of x, right? 0 into the corresponding marginal PDF, it is 1 by 2. It is also 1 by 2. 0 into 1 by 2, 1 into 1 by 2. So you'll get this 1 by 2. And this one is for expectation of y, minus 1 to the 3 by 8 and 1 into 5 by 8. So it is 1 by 4 and this is 1 by 4. Similarly for x square, we'll be calculating and we'll be getting like this. And if it is for the expectation of xy, it is double summation where it is like producting here 0 into minus 1, the corresponding probability, 0 into 1 with the corresponding probability, sum of all this 1 into minus 1 with the corresponding probability, 1 into 1 with the corresponding probability. So that is your expectation of xy, and it is here for this problem it is 0. So now make use of your correlation coefficient, the covariance formula, expectation of xy minus expectation of x into expectation of y, which is 0. This one we calculated 0 and this one is 1 by 2 and it is 1 by 4. So we got covariance as minus 1 by 8. So sigma x square, we have to calculate sigma x, sigma y. So we have to find the variance. So variance of x is expectation of x square minus expectation of x whole square. So using that we got it as 1 by 4. Similarly, we can perform for y. So we ordered sigma x from sigma x square, it is 1 by 2, and sigma y from sigma y square, root 15 by 4. So substitute in the Karl Pearson correlation formula, so covariance upon sigma x, sigma y. Covariance is minus 1 by 8, sigma x is 1 by 2 and sigma y is this thing. So on simplification, we got it, it is minus 0.2582. It is negatively correlated. Hope this is clear, right? So whenever the question is given, just identify it if it is continuous case or discrete case, so that you can find your mean, variance, and the corresponding covariance. Then we can find the standard deviation and substitute in the Karl Pearson correlation formula. Okay, so now the problem 1 shows you in the discrete case, right? Let us move for the problem in the continuous case. So the joint PDF of the following two-dimensional random variable is fx, y is given as 2 minus x minus y, where the range for x is 0 to 1 and range for y is 0 to 1. So now find the covariance and the correlation between x, y. So as I said, either discrete case or continuous case, we have to find the mean and variance of the given function, right? So here f of x comma y is given. So first I have to find the marginal distribution of x and marginal distribution of y. So marginal distribution of x is nothing but fx of x is 0 to 1 fx comma y dy. So integrate it and apply the limit, lower limit 0 and upper limit 1. So make the simplification and you will get the marginal distribution of your x. And so x range given it is 0 to 1. Similarly, you can find the marginal distribution function of here y. Fy of y is equal to 0 to 1 fx comma y dx. So substitute your upper limit or lower limit and make the simplification. You'll get the function 3 by 2 minus y. So the range of your y is, as mentioned in the question, it is 0 to. So now we got the Marshall distribution for both the variable x and y. So next I have to find the mean for x and y. So a mean for xy is expectation of x is 0 to 1 x f of x dx, and so substitute everything in the formula and simplify it, apply the limit 0 to 1, you will get 5 by 12. And similarly we'll find for expectation of x square, because we have to find variance also, right? So expectation of x square formula is 0 to 1 x square fx fx of x marginal distribution function. So 0 to 1 x square 3 minus 2x is your marginal distribution of your x dx. So perform the integration and apply the limit, so you'll get the final value. So similarly, so I have to find for your variance, right? Variance of x is equal to expectation of x minus expectation of x the whole square. So it's 1 by 4 minus 5 by 12 the whole square. So on simplification, we get the variance, that is sigma x square is 11 by 144. So similarly, we can find the variance of your y, where it is, again it is 11 by 144. To perform your covariance, I am supposed to find your expectation of xy. So that was performed here. It is nothing but expectation of xy. So double integration, where the range for x and y are same 0 to 1. So it is xy fx comma y dy dx. So your given function is 2 minus x minus y. So integrate with respect to y, apply the limit, then integration with respect to x, apply the limit, make the simplification. So you get 1 by 6. So substitute everything in the formula of the covariance. So expectation of xy minus expectation of x into expectation of y. So it is 1 by 6 minus 5 by 12 into 5 by 2. So finally we'll get it as minus 1 by 44. And we know it is sigma x variance, we got it. Sigma x is equal to root of 11 by 144. And sigma y is the same thing, root of x. So now perform your correlation. So it is R or L sigma rho of x comma y. Covariance of xy by root of dx sigma x sigma y, which is covariance we got it as minus 1 by 44, and standard deviation of x and y. So on simplification we get it is minus 0.09. So this is also again negative correlated. Not all correlation are negative correlated. There are cases which are positive correlated also, right? So next we'll move with the next problem. So two random variable x and y are related as y is equal to 4x plus 9. So we have to find the correlation coefficient between x and y. So till for the past two problem, we are given with x and y joint PDF. Now we are asked to find the correlation coefficient between x and y, where y is dependent on your x and the relation between x and y are given explicitly, which is y is equal to 4x plus 9, right? So we know the correlation coefficient formula is covariance of x comma y upon sigma x sigma y, which is expectation of xy minus expectation of x and expectation of y by sigma x sigma y. So now we have to find, to perform this one, we have to find what is your expectation of x, expectation of y, expectation of xy, sigma x, sigma y in terms of your given relation y. So first let me calculate expectation of x is same as expectation of x. So we have to find expectation of y. So using your property of expectation, expectation of ax plus b is nothing but expectation of ax plus b is nothing but expectation a times of your expectation of x plus b. So apply this, we'll get 4 expectation of x plus 9. Now expectation of xy. So expectation of x into y is 4x plus 9, simplified. So it will be 4x square plus 9y. Again apply your expectation property, you get it 4 expectation of x square plus 9 expectation of x. So now we use, we have to find the covariance, right? So substitute these two. This one minus the expectation of x and expectation of y. So expectation of xy is 4x, expectation of x square plus 9 expectation of x, minus your expectation of x is as it is. So expectation of y is 4 times of expectation of x plus 9. So make the simplification. So it is 4 times of expectation of x square plus 9 times of expectation of x. Here when we are making a simplification, it is minus 4 times of expectation of x the whole square minus 9 times of expectation of x. So on simplification, we'll get finally it is 4 times of expectation of x square minus expectation of x the whole square. So now we got the correlation as 4 times of expectation of x square minus expectation of x the whole square is sigma x square. Right? So it is sigma x square and it is also sigma y square when you're just performing it. So when you're just going with the variance of y, it is variance of 4x plus 9, which is 4 times of variance of x. So it's 16 sigma x square. So this is actually this one. There is a split. So it is not together. Sigma y square calculation is here. So it is sigma y is 4 times of sigma x. So covariance of x we got is 4 times of sigma x square and sigma x is sigma x and sigma y is 4 times of sigma x. So simplified. On simplification we will get 1 which is positively perfect positive correlation. Because we know it if it is 1 which is called as perfect positive correlation. If it is minus 1, perfect negative correlation. Right? So when you're just getting a relation like this problem, you have to go by this way of making all into the single variable and then complete your problem with the same variable. Okay. Hope you have understand this concept of correlation. So thank you so much.